All right, this is video number 2 of 5.2, the properties of rational exponents and radicals. Okay, this helps you with practice 5.2 on big ideas. And in this video, we're going to be using the properties of radicals. Okay, but first we need to go over some vocabulary, okay? So we have simplest form of radical. That's very important when answering some of these problems. It's an expression involving a radical with an index n. It is in the simplest form when these three conditions are met. No radicands have perfect nth powers as factors other than 1. No radicands contain fractions, and no radicals appear in the denominator of a fraction. All right, let's go over a few things, because even though it's not in the vocabulary, I want to explain what some of this means. So if I have a square root of something, or a root of something, so let's just say 3 square root of x minus 4, okay? The index is the 3, okay? That's the root, okay? This is just, the square root is the radical symbol. I don't need to really write that. But everything inside here, pretend that was like a little, horrible drawing, sorry. This is the radicand. It's everything inside the root. Okay? So, every time I use this word, that's what I'm talking about. Alright, so the next vocabulary term are like radicals. Okay? These are radical expressions with the same index and radicand. Okay? Alright, so core concepts here. We are going to have properties of radicals. We have the product property, where if they're multiplied inside, I can separate it out into 2, or you can go vice versa. Okay, if it's written like this and they have the same radical, I can combine them together to be 1. And then quotient property is just when it's divided. It can either be divided into 2 radicals, or it can be, if it's in 2 radicals, you can put it into 1. Okay? Alright, so now let's actually get to the problems. So we are going to be using the properties of radicals to solve. So number 7. In this one, my radicals are the same. So I'm going to write it as one radical. Third root, and I'm going to have 12 times 18. Okay, so that gives me the third root of 216. Now, if you can keep simplifying, this does say simplify the expression. So, if you know what that is, that's awesome. I am going to show you how to find it if you don't. If you go to math, remember the third root is number 4, and it's 216. Gives me 6. Okay, so this entire expression just equals 6. But if I were to try to take the third root of 12, it gives me a decimal. So if I were to write it down, I would end up rounding, and then same thing with third root of 18, I'd end up rounding. And when I multiply them together, I would get a decimal that's rounded and not exact. That's why we do this combination here. Alright, so now let's do number 8. Okay, so now I have a quotient here. They are both the fourth root, so I can rewrite it as 1 root of 80 over 5. And I can simplify that. 80 divided by 5 is 16. And the fourth root of 16, if you don't know it, you can use your calculator, but it is 2. Now, if it doesn't simplify to a nice pretty whole number, then you've got to simplify it in other ways, which we'll get to. But this one does, so that's great. So, like I said in the last video, we're going to jump around from practices. This video is not over, but 14, 15, and 17 in the practice go with number 7 and 8. Okay, so if you want, you can pause this video and go on and work on those. But we're going to now move on to number 9. Okay, Now all of these have a third root. So I can use the same kind of rules I did last time. I can take one cube root, and then I have a 5 inside times a 50 and divided by the 2. I just took all those third roots, basically kind of factored it out like the way we factor when things are similar here. All right. And now I've got to simplify the inside here. So I have the third root of 5 times 50 is 550 over 2. Okay. I don't know why I wrote 550. It's 250. I was like, that doesn't seem right. I need to, sorry, 250 over 2. I'm human. All right, and I can divide 250 by 2. I get 125. And I can take the third root of 125. So if you have trouble thinking of those, you can use your calculator or think of what times itself 3 times equals 25. And in this case, that is 5. Okay? So now let's go to number 10. Oh, actually, after number 9, do from the practice numbers 30 and 31. Like I said, we're jumping around here. Then we're going to go on to number 10. All right. So this time I have 2 things being multiplied inside my cube root. And I can't combine these 2 things because one's a number and one's a variable. So I'm going to separate this out. I'm going to use that product property a little different, and instead of combining, I'm going to separate it. So it's going to be the third root of 64 times the third root of y to the 6th. Okay? And if you can take a third, something times itself 3 times, equaling 64 is 4. And you can divide whatever the inside of my radicand, take that power and divide it by the root. Because remember we talked before in 5.1 where this is really the power over the root. Okay? And 6 divided by 3 is 2. Okay? Now not always will it go into it perfectly. So another way to look at this is if I have the third root, and that y to the 6 is the same thing as saying I have 6 y's. Okay? And this is a third root, so I want to group them in 3s. So I would group, here's one group, here's another group, and I don't have any y's left over, okay? So for every group of this, I have 1 y on the outside. So since I have 2 groups, I had y squared. Okay? So that's just another way to look at it. And when we get to, like, if you had y to the 7th, you'd have another y. And since it didn't group up, it would stay inside the root. So we'd have a third root of y left. All right. Just want to kind of throw that out there so I could explain that a little bit. Number 11 in the notes. All right. So again, I'm going to actually split this into 2 things. So everything is to the 4th root. So I'm going to separate it out so the numerator has the 4th root. And the denominator has the 4th root. Okay? And this one does the same thing. A 4th root and a 4th power, again, is the same thing as saying 4 over 4. In the base, that's a y, and it'll be 8 over 4. It's always the power over the root. Okay? Now, on 4 divided by 4 is 1. When this happens, you need to put an absolute value. Okay? Because it's no longer being squared or cubed, you need to have absolute value there, okay? When it comes out to being a 1. All right, you will have some in your practice that have an absolute value needed, okay? Now, here I get y squared, 8 divided by 4. Now, because this is still squared, I don't need that absolute value, okay? So that's as simplified as this one gets. All right, so now go to the practice and do number 49, 52, 54, and 55, and then go on to video number 3.